Hey everybody, welcome to this talk on a short history of Python web frameworks. I'm your host, Nafiul. I'm a developer advocate at Sonar. You can follow me on these socials. If you have phones, you can scan any of these QR codes and just have at it. I am a software engineer. I've been doing this for around 10-ish years. So I've learned a few things along the way. And so basically, I work at a company called Sonar. We are a clean code company. We have 3 products, Sonar Lint, Sonar Cloud, and Sonar Cube. Sonar Lint analyzes your code inside of your IDE to make sure you're not making mistakes. And Sonar Cloud analyzes your code in the cloud to make sure you're not putting in any security vulnerabilities. So if you get a chance, please take a look. And my colleagues are at the Sonar booth that you can also visit. So this talk has an interesting start. I had a very difficult time debugging some software, and so I started watching something that I call my comfort watch, which is Chuck. And in one of the episodes, there was this song called Once in a Lifetime. And it was asking these questions like, you know, what is this car? Where does this house come from? Because the person was completely confused. And I felt that way as well about my web server and my web framework. I was like, where is all of this? So basically, instead of solving the problem that I had at work, I just decided to investigate how Python web frameworks came to be. And that's how you have this talk. So where do you begin when you want to talk about a short history of Python web frameworks? Well, we begin in 1989. Some people were breaking down walls in the real world, and some people were breaking down walls in cyberspace. People started working on HTTP in 1989, and this is what the first version of HTTP looked like. This is 0.9, and we had GET requests back then, and that was it. That's all we got. People thought that maybe that wasn't enough, so in 1991, they came up with headers to tell you what's coming along your way. People realized that headers were a good idea, so they added more headers, because you need headers. And this is what it looks like right now. We're in HTTP 1.1, and this is what your request and response headers look like. If there are any mistakes on this slide, it is not my fault, it is Mozilla's, because I copied it from them. So a lot of things went well for HTTP. Byte ranges worked, so if you're downloading something and you want to chunk it, that's how you get that's how it works in HTTP. You have connection persistence, so you can make multiple HTTP requests on a single TCP connections. Chunk transfers, that worked well. But not everything worked well, so you had a lot of verbs in HTTP like options. And nobody uses options, right? There's this one guy who uses options. Okay. Hey, there are weirdos everywhere. But anyways, not everything went well, but something was still missing. And that is dynamic content. We want to be able to talk to a server and get a response back from it. Because let's be honest, we're developers, we can't talk to people, so we talk to servers. And that's how you have the Common Gateway Interface in 1991. It's called CGI, for those in the know. And it works like this. Your browser, it sends a request to a web server. Your web server then sends a request to something called a CGI handler. And the CGI handler passes along some environment variables to a script. Now, I know there's Python here, but let's be honest, back in those days, all those scripts were Perl. Let's be honest, right? Okay, great. And in this particular case, we have Apache as a server, we have mod CGI as a CGI handler, and it was forking this script for every single request. Some of you might realize that's not such a good idea. That doesn't scale very well. And we'll come back to that later. But anyways, this is how it works. So the CGI would basically put in environment variables, and then it would just take out everything that was in the output. So if you just print it out to standard out, that would just get handed back to the server, and then Netscape would be like, yeah, this is it. And this is how it worked inside of forms, right? You would actually have the name of the script inside of the form itself way back when. So in 1999, while parents were being bankrupt by their children into buying Pokemon cards, some really smart Python developers came up with Zope. So much so, it was so smart that, you know, this comic, it's not actually about Superman, it's about Zope, okay? And this is basically the Zope logo. And Zope is a framework that allows developers of varying skill levels, and I do mean varying skill levels to build web applications. That's not my words. That's from the Zope book. Okay? I'm not saying it. They said it. And if you really ask me if Zope was more of a CMS because you had all kinds of content in it, and I'm going to show you some of the stuff that was available in Zope all the way back then from the Zope book by Amos Latier and Michel Pelletier. It had an install screen. Yeah? Yeah? This is what a Zope terminal looked like. You have some HTML over here, you have some folders over here, and this is really what it looked like way back when. It had templating languages. You have stuff like if statements and variables. You also have something that was really new and advanced at that time, support for PDFs. Yeah. And you also had support for relational databases. If any of you have used Python, you've used scopg to talk to Postgres, this is where it comes from. And you could even view the tables and what they look like. And Zope is called Zope because it's the Z object publishing environment. Everything, and I do mean everything, inside of Zope was an object. Pages, templates, Python scripts, DTML, which was like their templating language. All of it was inside of this one database called ZopeDB or ZODB. And as you might understand, if you have one place that has everything in it, you're going to have some problems accessing it, right? And this is actually the Zope 3 book. This came right out as Zope 3 was coming out. And Zope 2 was one of the most influential open source projects at the time. It really set the tone for a lot of the other web servers that were coming out. And it's interesting that the Zope 3 book had this particular palace on its cover. Because this is the Patola Palace. This is a place that the Dalai Lama can never return to. And it's also funny because Zope 3 never reached the zenith that Zope 2 reached. Never reached it. Now you might ask why. Because Zope was all or nothing. It had everything in it. You used everything from Zope or you didn't. You couldn't really mix and match a lot of things. And it had a lot of things that were way ahead of its time. It had a lot of features that other smaller libraries did better, and so over time it lost traction. Another reason is because Zope 3 did have a lot of cool features, but people who used Zope 2 didn't want to go to Zope 3. So they used a library called 5 to get all the Zope 3 features in Zope 2. I mean, developers are going to develop, right? What am I saying? That's why this library is called 5, and that's why when Python 2 moved to Python 3, the library that helped you move was a library called 6, because 5 was already taken by Zope. Meanwhile, other parts of the Python world were working on alternatives to Zope. And one of the first alternatives was a framework called Quixote. And this came out in 2000. And this was named after Don Quixote. How many people know about Don Quixote? Some of you. Okay, great. So he was like just some guy doing whatever he wanted. Anyways, so it's kind of fitting because it's really the first modern Python web framework that was independently built. And it kind of worked like this. So you have like an entry point, which is the Q index. And you have this kind of template Python mishmash of things working together. So for example, this is a template, this is also a template, and this is referring to other templates that are declared elsewhere. So if you've ever worked with JSX, this came way before JSX. And it was really the first of its kind. It was called the Python templating language. But also, Webware for Python was also starting up back in that time. And Webware was a response to Java. Now, Java was rising rapidly at that time, especially Java server pages. And remember that pesky problem that we talked about where you would have to fork for every single request, and that wasn't such a great idea? Well, the folks over at Java were like, this is not fine. And so they decided to build a new architecture called the servlet architecture. So you have a web server in front, you have a servlet container at the back, so you have Tomcat or Jetty or Glassfish. And what this would be is this would be constantly running. Instead of forking for every single process, you have one process that's constantly running, and you just send it some stuff, and it sends you back some stuff through pipes. And so Python people thought like, hey, this is a great idea. Why don't we do something about that? And so they did. We had something called WebKit, which was kind of a response to your servlet container, and this thing would be constantly running. It was multi-threaded. It would get past all the environment variables depending on what you were using. So WebKit.cgi was used for development. Mod_WebKit for Apache was used in production. And it worked a lot like Java server pages. So you have like a class that inherits from page, and it writes out a hello world content. It's slowly becoming what we know today. And it was way ahead of its time. It had an ORM, so you could declare your classes in CSVs, and it had its own configurations, and you could of course get it via an ORM called MiddleKit. And back then, and I was quite interested to see this, back then Python had list comprehensions, and you could actually retrieve objects using list comprehensions with this ORM as well. This is what the Python templating, Python server pages look like. It's a mishmash of Python and HTML put together. And believe it or not, Webware for Python is still actively maintained, and this is from 2000. Now I have to pause here for a little bit. You're slowly seeing what we know to be modern web architecture coming together. You have your web server, right? You have your application server that's constantly running, and then you have your web framework. Like, your web servers are your Apaches, your application servers are your UISGIs, and of course you have your web frameworks like your FastAPIs and your Flasks. So a few moments later, well, a year later, we had something called WISGI, and this was the Web Standard Gateway Interface. And I would say this is probably the most important thing that happened in Python when it comes to the web. And what it does is that it allows you to interact with a web server using simple Python. There's no forking, nothing. You have this simple application, it sends you your environment variables, and it provides you with a function to handle sending the response back to the server. And so this is what a simple WISGI application looks like. If you copied all of this code and you just pasted it right now with WISGI and you ran it with GUnicorn, you need an application to run a WISGI application, it would run. That's all. You can see like the path, it points to a view function, and the view function just takes in environment variables, and it takes in the start response function that sends back responses back to the server. And this was amazing. This is Jon Stewart reacting to WISGI. True story. Anyways, so in 2002, we had CherryPy, and CherryPy was a confused little web framework because it couldn't choose between being a web framework, an application server, and a compiler, so it did all of that. No, I'm serious. So you had something called a CPY file. It had a class, a Cherry class called root. You could use mask to put in templating engine into your Python function, and you could mix HTML, variables and whatnot, and it was a hodgepodge of stuff. And I mean, you could still use CherryPy, of course. You can't do that anymore. It's a shame you can't. But you used to be able to do all this kind of stuff. But after 2005, the Python world was never the same again. Because in 2005, we had YouTube, and people started watching cat videos. But also, in 2005, we had TurboGears. Now, TurboGears was a response to Rails at the time. Now, Rails had so many good things going for it. It had an integrated full-stack framework, RESTful development, database migrations, scaffolding, generators, all this good stuff. And Python was like, hey, why are we behind? We can do this, right? And so they did. It was called TurboGears, and TurboGears is the rapid web development mega framework you've been looking for. And this is kind of how the layers worked. You had SQL Object, CherryPy, Kid, and MochiKit. And I'm going to go through how that worked. SQL Object was the ORM. It was kind of the answer to Active Record. And it was very simple to use. You had CherryPy, and by then, CherryPy had gotten rid of all its compilers and other stuff, and they're like, hey, we just want to be a web framework now. We're cool, so use us. So TurboGears used CherryPy to handle the controller and the view layer. And lastly, you had Kid, which handled the templating. So it was, you can actually see you're mixing Python as well as HTML together and all this stuff. So you see a lot of the stuff that you take for granted today and you use today, you know, these are the progenitors of that. And lastly, and this is my favorite, you had a JavaScript library called MochiKit. And I'm going to read out the description of MochiKit. There are lots of JavaScript libraries out there. One of the first things you'll notice about MochiKit is that you're not left guessing about how to use it or what's in there. Unlike the vast majority of JavaScript libraries, there is actual English text to describe how to use it. Tell me you're a Python developer without telling me you're a Python developer. So it was very passive-aggressive at the time. Now, TurboGears initially used CherryPy server, but it also became WSGI compliant later on. And at that time, people were talking a lot about how Rails is and different kinds of CGI. So we talked about CGI, we talked about WSGI. There were other CGI successors like FastCGI and whatnot. And there were some interesting people discussing about this, like David Hannemeyer Hansen, who was saying, like, what's wrong with FastCGI? It's absolutely great. But anyways, in this discussion, there was somebody who commented about this, and his name was Adrian Hlavati, and he was saying, hey, folks, you might want to check out this tiny little framework that we call Django. So in 2005, we had another big framework in the Python world, and that was Django, which is, frankly, currently the reigning champ when it comes to web frameworks in Python. And back then, I think the biggest selling point of Django was that it had an automatic admin interface. You could just deal with your databases in the web. You could do what you wanted with them. You could pretend like you actually knew SQL. It was great. And back then, Django used mod Python with Apache. So it didn't use WSGI to start, but eventually it did use WSGI. And this is kind of how it looks like. If you've recently used Django, this might look foreign to you, but we had regular expressions to capture different parts of the URL way back when. Of course, in 2006, Django added support for WSGI. But in 2005, we had another one. That was Web.py. Web.py is really interesting because this is the framework that powered YouTube. And it had all the stuff that you might want. Like, for example, it had Cheetah for templating. It had db.py, for databases. It had simple get and put requests. And you're slowly starting to see people just using get, put, push requests as as methods in classes in Python. But you also had another one in 2005. And 2005 really was probably one of the best years for Python. And that was pylons. Now, how many of you have heard of Pyramid? There is nobody who's heard of Pyramid. Great. Oh, there's one person who's heard of Pyramid. So pylons is the predecessor to Pyramid. And what was different about pylons, and this is something that a lot of us take for granted, is that pylons was a very modular framework. You could use any WSGI compatible server, any templating language, any WSGI middleware, any ORM. Now you might be thinking, hey, I already have that in Flask, but back then this was a new thing. You're looking at this transition from monolithic web frameworks to microwave frameworks that are able to plug and play different things. And I would say one of the biggest things that helped WSGI adoption was mod WSGI in 2007, and Python was never the same again. It just went to the moon in terms of adoption. In 2008, we had uWSGI, which is an application server. It's a reverse proxy, so it allows you to scale your Python frameworks better. And in 2009, I would say we had one of the coolest micro frameworks to come out in a long time, and that's Bottle. And Bottle was released after 3 days of coding. That is a real commit message by the person who created Bottle. And this is what Bottle looked like. Does it look familiar to any of you? Yes? Some, right? So this I would say is really the first postmodern web framework that is a micro framework as well. In 2009, we had Tornado. And Tornado was probably a renaissance in asynchronous frameworks for Python. And it needed to happen because at that time, Node.js was taking off. And Node.js was able to handle a lot of connections asynchronously. In 2010, we had Flask, which Does anybody here know Flask? Yes? Few people? Good. Oh, come on. So you had Flask back in the day, in 2010. Oh, what's going on? Oh, all right. But you might ask, why did Flask win over Bottle? Because they look very similar in terms, and they have very similar applications as well. The reason I would say is all of that, good idea, extensibility, support and maintenance, but really the community around Flask was just so much more vibrant than it was for Bottle. In 2010, we had Gunicorn. Gunicorn really is probably my go-to application server in 2010. And it was very fast. It used greenlets. So if you know about green threads, you can have threads within threads. And it was pure Python, so it was really fantastic. Now, to combat Node, in 2015 and 16, Python came out with ASGI. And ASGI really started off as something inside of Django called Django channels, because you wanted to deal with HTTP WebSockets back in the day. But ASGI required changing the way we dealt with responses, with requests coming from the server, and so we defined a completely different way of dealing with it. So this is a WSGI application. You have your environment, and you have your start response. For your ASGI application, you have your scope, which kind of replaces your environment, but you also have receive and send, which are functions that deal with WebSockets. And this is kind of what it looks like. This is an example of a scope. This is an example of a WebSocket scope. And in 2018, we had Starlet. Now, lots of people don't know about Starlet, but I bet a lot of you know about FastAPI. And Starlet is actually an ASGI toolkit. It's the thing that has made ASGI accessible to a lot of people. Similarly to how ModWSGI made Python easier to run on the server, Starlet allowed web framework developers to build on top of a toolkit. And if you use FastAPI, this is how much stuff FastAPI imports from Starlet. So you can really see that most of the heavy lifting is done by Starlet. And of course, in 2018, we have FastAPI, and what it does differently and so well is that it allows you to do sanitation and verification of your data using Python type hints. So people get a far more ergonomic way of working with data in their web framework, and it also ties in really well to Pydantic, which does a lot of the verification as well. So I guess what I wanted to say after all of this, and after seeing all of this and not doing my work, and instead going down a rabbit hole, is that we really stand on the shoulders of giants. We have inherited a legacy of ordinary software engineers and developers doing extraordinary things, and I hope this talk inspires you to live up to that inheritance. Thank you very much.